Okay guys, today we're going to be doing some problems out of section 6.1. We're going to be doing the law of sines today, which some of you may have seen before. A few notes before we get too far into this. You guys will need a calculator for today, and you do need to double check and make sure that you are in degree mode. If you're in radian mode, none of this is going to work. So please get a calculator, make sure that you are in degree mode. Okay, so what we do in chapter 6 is we move away from the right triangle trig and move into non-right triangle trig. And non-right triangles are called oblique triangles. That just means that they are non-right triangles. All the trig that we've done so far has involved right triangles, and in right triangles we can use SOHCAHTOA. Well, in oblique non-right triangles we cannot use SOHCAHTOA. So we have to use some other things to find missing sides and missing angles, and that's what we're going to be doing over the next few sections. So I want you guys to realize that we're going to have just a generic non-right triangle. You can draw any right triangle or any non-right triangle you want. This is usually the one I draw. And we're going to use capital printed letters to represent angles. So for instance, here I have triangle ABC, and then my sides will be lowercase printed letters, and they'll be opposite the appropriate angles. So like side A is opposite angle A, side B is opposite angle B, and side C is opposite angle C. Okay, so that's the generic kind of non-right triangle we'll be working with. Now, moving on to actually remind you guys what the law of sines is, because I think most of you have at least seen this before, maybe not. But if you haven't, this is what the law of sines formula actually is going to look like. So this goes back to that triangle we just drew. In that triangle, the following ratios are going to be true if we set them up in proportion form. The sine of angle A divided by side A is going to equal the sine of angle B over side B is going to equal the sine of angle C over side C. So all of these ratios are going to equal each other. So depending on the pieces of information given, I can set up some of these proportions and cross multiply and solve for a missing piece. Okay, here's the big piece of when do I use law of sines versus when do I use law of cosines. We can use the law of sines if we know a side across from a known angle. In other words, I would be able to set up a complete proportion or a complete ratio where I know everything, and I'll show you what that means here in the next example. Now, if I don't know a side across from a known angle, then I cannot use the law of sines, and we would have to use the law of cosines, which will be in a unit down the road. Okay, so let's take a look at this example. So in this case, I'm going to tell you that the measure of angle C is 102. That looks really bad. Let me erase that here. 102.3 degrees, and angle B is 28.7 degrees, and side B is 27.4, we'll say feet. Okay, so what you will usually see me do for a problem like this is I'm going to go ahead and draw a triangle and label it so that I can see what I know and what I don't know. So for instance, on this one, I know that angle C is 102.3, so obviously my picture is not drawn to scale, but that's okay, it doesn't matter. Angle B is 28.7, and side B is 27.4 feet. Okay, so the pieces that I'm missing here, I don't know what angle A is. I don't know what side A is, and I don't know what side C is. Those are the three things that I need to go through and figure out. Okay, now, first of all, is this a law of sines or is it a law of cosines question? Well, we said it would be a law of sines question if I know a side across from a known angle. So if I go back up here, you can see that I know angle B and side B. That means that I know a side across from a known angle. So therefore, I can write a base ratio of sine 28.7 over 27.4. If I can write a complete ratio like that, then I can use the law of sines. So that immediately tells me it's a law of sines question. Now, let's see if we can find the three missing pieces here. So first of all, for angle A, in order for me to find angle A, I've got a triangle. I already know two of the angles. I do not need trig to find that angle. To find my missing angle, I just need to know that all three angles add up to 180 degrees. So on your calculator, type in 180 minus the two given angles. So minus 102.3 minus 28.7, and we should find that angle A is 49 degrees. So angle A, so we can see that angle A is going to be 49 degrees. Okay, so I've got that. So now, for me to find side A, if I look at my picture, I have my base ratio of the sine of 28.7 over 27.4. To find side A, now I can set that equal to the sine of 49 over A. Now, how do I solve that? I cross multiply it. A sine 28.7 over 27.4 sine. That's all wrong. Sorry, let's back that up. I'm going to erase that. My bad, sorry. My brain is wandering here. Equals, so I cross multiplied here, now I cross multiply the other direction. 27.4 sine 49. To solve for A now, I simply divide the sine 28.7 over, and now I can type all that into my calculator. So 27.4 times the sine of 49 divided by the sine of 28.7, and that's going to tell me that A is 43.06, and that's feet. So now I have one thing left to find, which is side C. I'm going to simply set up another proportion and cross multiply that. So sine 28.7 over 27.4. Your base ratio does not change. For that, I'm going back to my given information. Now, to find side C, I'm going to set that equal to the sine of angle C, which is 102.3 over side C. And now, just like I did on the last one, I can cross multiply all of that. So in my calculator, I'm not going to write this out, 27.4 times the sine of 102.3 gives me like 26.77. We're going to divide that by the sine of 28.7 to find that side C should be 55.75 feet. Okay, so that's my answer set for that problem. Okay, we're going to do one more example here for law of sines. Okay, so for this one, let's do this for my next example. I'm going to tell you that side A is 22 inches. Side B is 12 inches. and angle A is 42 degrees. So again, if I draw a triangle here, A, B, C, I can see that 42 goes there, and 22 goes there, and 12 goes there. So all I'm using that for is to say, yes, I've got a base ratio here of sine 42 over 22. And that's again because I know side A and angle A. If I know the side across from the angle, then I can use the law of sines. Now, what am I missing here? I don't know what angle B is. I don't know what angle C is. And I don't know what side C is. Those are my three missing pieces of information. So in order for me to solve for something here, the only other thing I know right now is side B, which would go on the bottom, and that would be opposite angle B. So this is a little bit different. So let's cross multiply and solve here. That would give me 12 sine 42 equals 22 sine B when I cross multiply, but that 22 I'm going to divide over. So now we're going to type that into the calculator. 12 sine 42 divided by 22 gives me 0.3650 basically equals the sine of angle B. So now from here, in order for me to find angle B, I have to get rid of sine, and the way we get rid of sine is to do the inverse sine of B. So on your calculator, you're going to press second sine of that last answer, the 0.36498, whatever. And that tells me that angle B is 21.4. So angle B, 21.4 degrees. Well, now that I know angle B is 21.4 and I already know angle A, I can simply do 180 minus the two given angles, 42 minus the 21.4 that we just found. We can find that angle C is 116.6 degrees. And now that I know angle C, to find side C, I simply set up another proportion. So I would have the sine of 42 over 22, that ratio isn't changing, equals the sine of 116.6 over side C, and now cross multiply that and solve. So 22 sine 116.6, we're going to divide that by the sine of 42 and find that side C is 29.40. 29.4, and that was in inches. So there is law of sines.